Okay, as you know, if you've been out to the crime scene, you know there is a white substance found at the crime scene, and we want to try to figure out what drug it is. So in order for that to do that, you're going to have to do some chemical tests, and you're going to have to compare it to some drugs that we know the reaction to. So first, we're going to talk about controls and negative, positive controls, and then you guys are going to do the chemical test. So first, I just need to give you some background information on what these two things are. And so you should be taking some notes on this information before you do your drug test. So just open up your notebook and make sure you get down this and pause the video whenever needed. So first, a control group, you might have talked about this in bio, is something you're going to compare your experiment to. So for example, we have an unknown drug sample, and then we have all those known drugs. Those known drugs are controls. We know what their reaction is going to be, so we can compare them against the known drugs to the unknown drugs, and whichever one's similar is the unknown is that drug. In this case, on your slide here, we have fertilizer and another fertilizer. What this says here is this is going to be the new fertilizer. So you would have to compare it, because if you just grow the new fertilizer, you'll never know if it actually works any better if you don't compare it to something. So you always need to compare your experiment to something, and that is your control group. So you'll always have at least two groups in your experiment. All right, so now here's some practice. So pause it now, read these, and see if you can figure them out. And then when you hit play, you'll see the answer, because I'm going to tell you the answer. Okay, so hopefully you tried to look at these. So we have our bacteria one. The bacteria control group would be, you could possibly have two. Obviously, you would need to know if you're trying to figure out if the lettuce is contaminated with bacteria, first you would need lettuce not contaminated, because maybe your plate is contaminated. And then you mistakenly think the lettuce has bacteria. So you do run a control where you know where lettuce is not, and you should expect nothing. And that's just to make sure your experiment works. The other one is you could actually use that actual bacteria you're looking for, and you can compare, you can try to grow that bacteria and make sure it grows. So there's two possible groups, and then you have your experiment would be the proposed lettuce that's in question. So then if something grows, you compare it to this one and see if it looks the same. If nothing grows, well then hopefully it's not contaminated. If something grows on this, then you know there's something wrong with your experiment. If nothing grows on this, then maybe you used the wrong plate or the wrong growing procedure. So that's why you use those. It's one, to make sure your experiment works, and also to verify the results. The second one here is the drug in lowering blood pressure. So the drug, you could give the previous drug, or you could give no drug, and often that's called a placebo, because you want to see if it's just in their head that's lowering the blood pressure. So you can always have this new drug, and you have to compare it to either previous medication or a placebo or no drug, and see what exactly is going on. Or you can at least definitely compare it to their previous blood pressure. You take their blood pressure before the medication and a blood pressure after. And that's kind of like your control too, is that first one is to see if that blood pressure medication actually works. But you still want to do these two to make sure it's definitely, one, working better than the previous medication, and two, it's not just in their heads that this blood pressure medication is working. All right, so now stop, go through that success criteria, talk with your partner, talk in your group, make sure everyone knows how to do that. Go to the soapbox and say if you're confused or not, or call me over if you're confused about just in general what a control group is. Okay, now the next success criteria is a positive and negative control. So you guys can read that. A positive control is basically you expect the result. All right, so if you're testing an unknown drink contained with sugar, you should test a sugary solution. which is a positive control with a chemical to see what color it turns. So we know it has sugar, therefore we want to see what sugar is going to look like. And that gives us a positive control because we already know it has sugar. And then if we test this solution that we think has sugar in it and compare the two, so this gave us a positive result or a no result. So that's a positive control. A negative control is an experiment that is expected to not have an effect. So if we're doing our sugary drink, water, we don't expect any sugar in water unless somebody tainted the water. So we do an experiment, we do the same test with water as we did with the sugary solution, and you should expect no result unless it was tainted. So that means your experiment is messed up or something like that if it turned the color. So that verifies your experiment, plus it sees what no result should look like. So that's a negative control. Here's a good example of what I was just talking about. So here's the sugary drink over here, the purple one. It's a sugary drink. It turned purple because sugar turns purple. The negative water didn't turn a color because there was no sugar in it. So then you would have your third little, it's not letting me add. You would have a third sheet of this, a third tube, and you would compare it to the purple and white. All right, so if, again, with the lettuce and this, just pause it and see if you can figure out which one would be the positive and which would be the negative. All right, so here's the answer. Obviously, the one with not contaminated is the negative. And this one's the positive because we expect nothing. We should know what the result is. And then here, previous medication would be a positive control, and this would be the negative control. Again, we're given something, we know what the result should be. Positive control, nothing, no result. All right, so now, go back through your success criteria again. Make sure you understand what a positive and negative control are. Call me over if you don't. Make sure you talk about it, have everyone give input. So now finally, the drug station, make sure you follow the directions. You're just putting a little bit of each drug. Make sure you don't mix the drug, don't taste the drug, don't smell the drug. These are obviously simulated, so it's not going to hurt you. But you still shouldn't do that. That's best practices. And you're going to test them against. So each person can take a different drug, do the test, and record your evidence. All the directions are on there. Make sure you understand the directions before you start.